Smart Aqua for Future, SAFE, is a Horizon Europe-funded project aimed at reducing the environmental impact and improving the viability of freshwater aquaculture by applying circular economy approaches. In SAFE, side streams from recirculating and integrated multi-trophic aquaculture systems are valorized into 4 novel fish feed ingredients to replace fish meal and fish oil in fish feed. In this video, we will demonstrate the semi-continuous cultivation of microalgae in the process water of the recirculating aquaculture system, later referred to as RAS. The algal cultivation is carried out by the Finnish Environment Institute, one of the 15 partners in the SAFE project. The Finnish Environment Institute is a state research institute under the Ministry of the Environment. We have approximately 700 employees across 4 locations in Finland, providing research, information and expert services on environmental and natural resource issues. About 2/3 of our funding is external project funding, which highlights the importance of close collaboration we have with universities, other research institutes, companies, and public organizations both nationally and internationally. Our 5 solution units focus on climate, circular economy, built environment, nature, and marine and freshwater topics. Together with our supporting units, which provide infrastructure, services, and help decision-making in society, we work closely towards our strategic goal, a sustainability transformation. The Marine Research Laboratory at the Finnish Environment Institute has a temperature-controlled experimental room equipped with 12 320-litre cylindrical reactors, which are used for the cultivation. RAS process water from a Finnish freshwater rainbow trout farm is used as a medium for the algal cultivation. The RAS process water contains not only nutrients, but also other organisms, such as ciliates, flagellates, and other algal species, which must be removed before the water can be used for algal cultivation. In SAFE, we filter the water sequentially through 5, 1, and 0.2 micron filters and treat the filtrate with UVC to ensure its purity. The diatom species Phaeodactylum tricornutum was chosen for the cultivation due to its fast growth rate and high content of polyunsaturated fatty acids, primarily EPA. An inoculum cultivated in autoclaved RAS process water is added to the cultivation unit. Additionally, phosphorus is added to lower the molar nitrogen to phosphorus ratio from over 45 down to a more optimal range of 8 to 10. Trace metals must also be added, as some, like manganese, are at too low levels in the RAS process water to support microalgal growth. Light is provided 24 hours a day using external lamps, and air is continuously supplied for mixing. Additional carbon dioxide is added as needed to control pH. The cultivation temperature is maintained at around 20 degrees Celsius. After around 3 weeks, the cultures are dense enough for the first harvest. The diatom's ability to excrete slimy material, called extracellular polymeric substances, is exploited in the SAFE project. The slime helps the cells aggregate, which promotes faster settling and allows the collection of concentrated biomass. This significantly reduces the energy consumption required for the harvesting process. Here, aeration was stopped for 4 hours before collecting the concentrated biomass through the valve. Once the biomass has been collected, the aeration is turned back on, new RAS process water is added, and the cultivation is continued. The semi-continuous mode shortens the time between harvests, and in 1 to 2 weeks, the biomass can be collected again. To enhance the production of long-chained polyunsaturated fatty acids, like EPA, the collected biomass is further cultivated under nitrogen-limiting conditions for up to 5 days. After this, the biomass is collected through centrifugation to remove as much water as possible, but without breaking the algal cells. The thick biomass paste is then frozen at -20 degrees Celsius. The frozen biomass is freeze-dried, and the dried biomass is immediately vacuum-packed to prevent lipid oxidation. The biomass is now ready for the SAFE feed trials. For further information on the SAFE project, please visit our website.